So yeah, while we're waiting, I'm here, and if any of you have any questions about data science or analytics that you would like to talk about, I'm happy to answer those questions while we wait for others to join in. I know that some people are supposed to join in; they're running a few minutes late, so we'll wait for them. But if any of you have any questions, feel free to go ahead and ask. I'm here for the next few minutes before we start off. And it can be it does not need to be about data-driven decision. It can be pretty much about anything in data science and analytics and machine learning and AI in this field for close to 20 years. So anywhere where you think you want to pick my brains, I'm happy to answer.
So let's begin with the webinar today. Welcome everyone. Thank you for joining us. My name is Mahima and I'm a part of the engagement marketing team. I'll be your host for today. I will start this webinar by telling you a little about this platform, which is Hero Wired. So Hero Wired is a virtual education company, which is a part of the Hero Group. So we are on a mission to not only reimagine the way we learn, but also build a better and a brighter future. We are also here to equip our learners with the right skill set, the right knowledge, and the expertise that they need in order to find success. Today, we are presenting this webinar on the topic, which is best practices for data-driven decision making by Dipyaman. So I'll tell you a little about Dipyaman as well. So Dipyaman is a PhD in economics with an experience of 15 plus years. He is among the 40 under 40 data scientists of 2019 in India and the leading data science academicians in India in the year 2018 and 2019. So moving forward, I will be running a quick poll, everyone. You can see the poll on your screens where you need to provide us with few basic details about yourself. So I'm quickly running the poll. You can go and do the polls. I hope everyone can see poll on their screens. Also, during the webinar, if anyone have any questions regarding this webinar related to data science, please feel free in order to put down your questions in the Q&A section. Do not place them into the chat box because in the chat box, it might get skipped. So make sure you're putting your questions in the Q&A section. So without any further ado, over to you, Dipyaman. You can go on with the webinar.
All right, thanks, Mahima. Thank you very much. Appreciate the introduction and for that the small addition for the Data Science Academics Award. It was 2017, 2018, and also this year in 2022. In all their wisdom, the good people at Analytics India magazine decided to give me the award again for a third time. So very kind of them. All right, great. Thanks everyone for joining. I'm gonna talk about data-driven decision making. Some of it will be from the slides that I'm going to present, and I'm gonna just go ahead and share my screen. But some of it will also be just from my experience, like stuff that I have done over the years and so on. Yes, because I mean, if it was just the slides, I could have given you the slide deck. Yes, that's I don't think super helpful. What I'll try to do is bring in some of my experiences from the industry and working across different kinds of organizations. Close to 19 years now, a little over 19 years now. So from pretty much from 2003. Yes. Um, and I've been working with or learning about data for even from even before that because I'm an economics graduate and so on. So we started doing data work very early. Right? And over the years, I've worked with um, started off with financial markets where decisions needed to be taken and it had to be data driven and it had to be very fast. Moved on and worked in a variety of different kinds of industries and organizations. Right, I run a consulting firm for the past decade now, where we have worked with government agencies, we have worked with um, e-commerce firms, we have worked with job portals, we have worked with finance companies, we have worked in HR, marketing, you name it, and we have probably done something right somewhere. Yeah, and that's the beauty of data science or data-driven decision making or business analytics or whatever you want to call it, is that the skills are extremely fungible, right? And so, what do we mean by fungible? That means that it can be used by pretty much every field across disciplines, across verticals, and across different types of companies. It doesn't. You don't need to be a very large organization to use data-driven decision making. Right? You don't need to have extremely high quality data or big data, right, to take your decisions using data. You can have extremely small data and still be using data-driven decision. So I'm going to begin with the slides, and then, of course, if you have any questions, please feel free to ask at any point. What are we going to talk about? We're going to talk about analytics and its applications. We're going to talk about the different types of analytics and how it's used for problem solving. Yeah? So broadly, the first question that we need to ask ourselves is, what is analytics? We keep hearing about it. What is analytics? And I'm going to use the term data science and analytics a little interchangeably. While they might mean something which is a little different, there's no sharp distinction between where analytics, business analytics ends, where data science begins, or for that matter, even where data science ends and machine learning begins, or for that matter, where machine learning ends and AI. There's nobody standing there with a line saying, "Hey, this is where it stops." Yeah. So, what is analytics? It's the art of discovering insights from data. Yes. And it doesn't need to be large volumes of data that the slide talks about. It can be small volumes of data. Necessarily even need to use mathematical and statistical models. You can run exceptional analytics by just creating these rules and bringing out visual analytics, right? Building beautiful charts, graphs, and dashboards. Yes. Of course, if you want to go further and start making predictions, right, which is called predictive analytics, at that point, you really need to learn the mathematics and the statistical models, right, or at least how to implement and utilize them. So when we talk about data per se, that's just volumes of little bits and pieces. There is nothing called you cannot really look at data and come to decisions. So the raw data, which we see on the left of our screen, comes from different sources, right? Point of sale systems, social data, web data. We process it, we summarize it using summary statistics or exploratory data analytics or visualizations, and that data, that raw data becomes information. Yes? That information then, when it's made into something that's relevant, yes, and actionable, that hey, can I do something with the data? Yeah, that kind of becomes the knowledge, yes, and hopefully that leads to wisdom of taking strategic decisions about an organization. Again, when I say organization, I mean it in the broadest sense of the term. It doesn't need to be a company. It doesn't need to be a technology company. It does not need to be anybody who has lots of data. It can be a government organization. We have worked with the government. I have worked with the government extensively. Different agencies. It can be somebody who manufactures bicycles. Even manufacturing industry. It can be a not-for-profit. We have worked for multiple not-for-profits, right? NGOs. Yes. It can be an educational institution. So it doesn't matter where you work, the type of work. Yes, it's across. And suddenly we are seeing that it's extremely popular, right? We have this whole analytics, data science, ML, right? It's become kind of a flavor of the season. The question that we all ask is that why? Right? I've been doing this for a long time, as I said, from 2003, I've been closely involved in data and analyzing data as a professional. people didn't care about this stuff so much, right? Other than in some industries. In finance, where I started off, it was always big, right? Analyzing numbers and putting on trades. But in most other industries, yes, it was not something that people cared about so much. We do a little bit of statistical models and so on, some dashboards, but not much. But over the last 7, 10 years, it's just like spiked. Yes? So what happened? Managers want to take the best possible decisions. They realize that not taking data-driven decisions, right, lead to a lot of biases in decision making. Right? There is no method by which a decision is taken. It becomes completely dependent on the individual and their gut. Right? That in itself is a huge problem which we try to change. Yes, which we have been trying to change. If you look at the cultural change, it's a shift from old-fashioned intuition-driven decision into new age fact-based or evidence-based. That cultural change uh, has had a profound impact, okay, across the board of leadership and of management. The way decisions are taken at the highest level today and the lowest level today. Right? The junior most person trying to take a decision that, hey, I'm trying to sell something to someone, what level of discounting can I do? That decision, right, has become data driven as well. To at the CXO level, that, hey, I want to do $1 billion acquisition. Should I do it or not? There are numbers behind these largest and smallest decisions today. Okay? The other big reason is that availability. Tremendous amounts of data have become available. Storage has become cheap. Computation on that data has become more plausible. It's because back in the day we just couldn't. And the core behind data analytics is learning from history. Okay? Uh, in the there's a guy called Nate Silver. Yeah, he's a data scientist, if you will. He used to make predictions about baseball games, yes, and he used to bet on baseball games. And then he realized that he could also make predictions about elections in the United States. So he started doing that. And in 2012, he correctly predicted the results in all 50 states. Okay. Then he kept doing that and kept being incredibly successful over the years. But sometimes, right, some of the methods that Silver was using, he's a Bayesian, right? He uses Bayesian statistics. Sometimes those fail. In 2016, most forecasters couldn't predict that Donald Trump would become president. Now, what is the context for this in India? Because you might say that, okay, poll of polls did work, didn't work in the United States. They have a lot more data. The reason why it failed is that a lot of people, after when they were taken, the exit polls were taken. A lot of people didn't want to say on camera or otherwise that they voted for Trump because it was uncool to vote for Trump. So nobody actually said that. So there was a systematic bias which impacted these polls, and therefore most forecasters could not predict correctly. Yes. Now, what's the context in India? How many of you know about the amount of work that's going on today in India? Oh, somebody says that can't hear properly, voice is not clear. Is that true for anybody else? Can you all hear me? Am I audible to everyone? Yes, I had a question. Am I audible to you? Can you hear me? Oh, am I audible to everyone? Can you all hear me?
Hi,
Okay,
Deep. Yes,
all
you're
right.
audible. Yes, you're audible.
Okay, yeah, that's why I was asking that because I saw a message right now. All right, so I'm gonna just stop the share for a second and ask, just have a few. I think there are a few questions on the chat box. Let's see what we have. We'll try to answer those. Yes, I saw there were a couple of questions. I think any questions that you have, right? Because I'm going to talk about the Indian context now, right? We talked about Donald Trump and his elections. I saw one question on what methods did he use for making these predictions. There's something called Bayesian statistics. It's named after a man called Reverend Thomas Bayes, Bayes. What Bayesian statistics allows you to do is that you make a prediction, right? And then let's say new information comes in, okay? It allows you to update that prediction very well based on new information. So what Silver does is he uses method from Bayesian statistics to keep updating, right? Every time a new poll of when a new poll happens. So let's say every company runs an exit poll data comes in, Silver manages it, makes a prediction. New poll comes in, updates the prediction using Bayesian statistics, comes up with a. So he never claims that he's an expert in U.S. politics because he used to make these predictions for baseball games before that, which has nothing to do with politics. Yeah, and that's the power of data-driven decision making. It's like you would find CEOs, right, moving from one industry to another at a junior level. If you work in an insurance sector, right, you know that if you want to move to IT tomorrow, right, or if you want to become move to the fashion industry tomorrow, maybe doing the same work, right? You're from moving from insurance sales to fashion sales. It's very, very difficult. Yes, after 5, 10 years of doing this, it's not easy. It happens. People do it all the time. I have had so many of my students move, shift, change careers, obviously, but it's not easy. Whereas at the CEO level, you'll see that somebody who works in FMCG suddenly becomes the CEO of a newspaper because the skill that they have is fungible. That means it's transferable. Yes. And in this case, the skill that the CEO has is leadership. Yes. The good thing about analytics is that you don't need to be the CEO to have a fungible skill. You can be a fairly junior person and move from one domain to another. Yeah. Um, so from analyzing baseballs, if you can analyze what's going to happen to a particular election. Yes. Uh, what's happening in India in terms of analyzing data for elections? Um, between in the last 10 years, right, pretty much from 2010, 12 to now, the way elections happen in India, and it's a large country. Data is not easily available. It's very opaque, right? In the last 10 years, is my screen visible again? Quick question to everyone: is my screen visible? Yes. Okay. Great. Fantastic. Okay. All right. So what's happening here in India is that whole booth level data is being collected. People are collecting information from variety of local sources which you might not even know about. Yes, and that data is getting analyzed, and the outreach from different political parties, every political party, their messaging, what sort of candidate to send to poll in a particular state, in a particular municipality, right? Uh, that pulse of the people, that's today being collected across the board, and and the idea of these expert pollsters sitting and making predictions based on, hey, this is what should be done, that's over. That data is now getting analyzed and crunched by data scientists. Yes. Some other areas of application: finance, fraud and risk detection. BFSI is the largest you know, um, industry, hiring industry for business analytics and data science. Yes. Because think about default, the biggest question that a bank needs to understand. Right? Think about fraud, from insurance companies to banking to any financial services, huge for them, huge, millions and billions of dollars lost every year. Yes. So banks use the data from their customers' profiles, their recent expenditures, and so on, right, to create a persona for the customer. And anytime an expense that happens, which is not like them, right, it gets flagged. Right? Let's say most of my spending is in the state of Karnataka, and suddenly I go to travel and I swipe my card in somewhere in Europe. Yes, your bank is going to just reject that transaction unless you have pre-informed them that, hey, I'm going to travel, because their flag will show up that, hey, probably this is a transaction which is fraudulent. Yes. Healthcare treatment optimization, the amount of data that's coming in healthcare today is enormous, right? Patients coming in, what is all their test results, what sort of blood work did they get, what did the doctor say at the end of it, what prescription was given to them, was the prescription filled or not. This entire chain, right, today across the world is getting digitized. Hospital management systems are being used across the board in India now. Every large organization, Dr. Devi Shetty of Narayana, he's one of the big names in the medical world in India, who's trying to utilize data science and data analytics in hospital management, and also in detection and things like that. He's been on multiple panels and conferences talking about this stuff. Yeah. Logistics. If you think of the amount of deliveries that we get today versus what we used to get 5 years back, you can realize so anything that you're buying today, right? Most of it is coming through some sort of a supply chain. And that supply chain, which was very simple before, today is being completely optimized by these larger organizations. One of the companies, Delivery.com, right? They've become a unicorn now. I think they were started about a decade back because some young people living in Gurgaon found that their pizza was not getting delivered on time. So then they kept asking around, and they realized that delivering things was a big problem, right? Even though there are lots of courier companies out there, the DTDCs and the DHLs of the world. So these guys then, I think 7 or 8 IIM Bangalore graduates, they landed up opening a company, and today it's become a unicorn. They're in 300, 400 smallest of towns in India delivering things, right? Because you have the Mishos and the Amazons, which actually are now delivering pretty much anywhere which has a pin code. Yes. So everywhere that you look at, right, businesses are taking decisions using numbers or using data. The process of taking decisions traditionally is over. Governments, especially with smart cities. Now, we all heard about smart cities. It was a big initiative, and we know that the initiative did not work out well. Right? What was planned for smart cities versus what landed up happening. There's a very large gap. However, I think which is true, and it didn't match up to expectations. Fair enough, but there was a mindset change, right? That government officials, folks in the government, folks in the bureaucracy, and so on, they started thinking that, hey, if I get the right kind of numbers, I will be able to make different types of changes. If I have data from mobile phones, yes, that hey, this is where people live because this is where their mobile phones are most of the day, and this is where they go to work because you have the GPS data of this person going from this place to this place pretty much every day, Monday through Friday. Then these are the two areas of the city which needs the best traffic linking. This is a project that was done in Kenya using Orange Telecom's data, where the government decided that where should they build the next public transportation system, because the biggest challenge for the government is what? They want to do a lot of things for us, but they have a limited amount of money. The government can't just keep spending. So the government has to optimize what it should spend its money on. And the way the government in Kenya optimized it is by looking at data from Orange, right? Saying that most people live here and they go to work here, right? Based on their travel paths, on their phones, and their calling patterns. That during the day, if you're in office, you would make calls to your home mostly. Yes? So using these call patterns, they figured out that which is the area where from people go from place A to place B. And that's how they decided how they're going to build roads and how they're going to build public transportation. Yes. So as you see that the application areas are just becoming absolutely enormous. Right? From Uber doing loyalty programs to Inspirian doing fraud detection automation. Global cybercrime costs reached $1 trillion in 2018. Can you imagine in the last 3 years, I'm sure it's gone up to probably $2 trillion. 92% of target organizations reported negative effect. Banks, insurance companies, all sorts of credit card providers, um, anybody effectively who has a website is potentially at a danger of being affected by cybercrimes, right? So these guys came up with a hybrid approach of supervised and unsupervised machine learning and animal detection engines to figure out what is fraudulent behavior. The problem with fraud detection and why we talk about it so much is that it's extremely difficult in real life to detect fraud because fraud it's a rare event. Let's say think about bank defaults, right? That somebody takes a loan from a bank and they default on that loan. If you look at banking data, you will see that the number of defaulters for 100 loans are going to be anywhere between 7 to 8. Right? So we're looking at a 7%, 8%, in some cases 10% default rates. So what you can do is look at the pattern of the defaulters. You can also look at the pattern of the non-defaulters and see that what is the difference in their behavior, right? Because for every 100 loans given out, 10 are defaulters, 90 are non-defaulters, okay, regularly. The problem with fraud is that if there are 100,000 credit card transactions a day, right, for your organization, there'll probably be one fraud during the day or two. So finding patterns in that little data when compared to this large data is extremely difficult. You don't have enough information to say, okay, you know what? Just because 2 out of 100,000 are fraudulent, yes, this is what the fraudsters look like. You won't have enough data to identify a pattern for them. Yes. So detecting fraud is extremely difficult, and we use some things called anomaly detection techniques and unsupervised machine learning. Yeah. Think about Netflix. All of you have used Netflix, I'm guessing, or most of you have. If not, you've used some other platform like that. What Netflix did and what Netflix does is every time a customer interacts with Netflix, right, it keeps collecting the data. What you saw, right? How often do you see Netflix? What kind of shows do you see? What kind of movies do you see? Right? Did you press like on a particular movie? Based on that, what type of movies, and so on and so forth. Right? Recommendation engines for Netflix are some of the most powerful in the world, which is why customer retention rate at Netflix is 90%. That's on the highest in the whole wide world. Because every time you watch a show on Netflix, they know very well using analytics that what is it, what else are you going to like? Because if there are 100,000 people who are very similar to you in types of the shows they watch, if they like a show which you haven't seen yet, Netflix is going to recommend that. They'll say, okay, you know what? Person A and B liked a particular show, which person C, D, E also liked. Now let's figure out what did C, D, and E, what else did they like, and recommend it to person A and B. Right? And these recommendation engines keep churning out what you would potentially like. Think of Amazon. Every time you buy something on Amazon, they'll say that, oh, you bought this, you might also like this. Yes. Now, and that's great, right? Because Amazon makes those predictions based on this recommender system, and those recommender systems are quite impressive. It helps you, let's say if you buy a book or a certain type of book, let's say you're interested in data science, go buy a new book on data science. Amazon will give you predictions and saying recommendations saying that, oh, you know what, you bought machine learning using Python. There is another book called Data Science Using Python, which is very good and being recommended by people who read this book. Yeah, that's that's the kind of stuff that happens today, and that has changed not just online buying patterns, but it has also changed offline buying patterns. How do you think when you go to a store, a large store, not a small store, right? A chain store, a big bazaar, let's say, who decides that what article or what item in a big bazaar is next to another item? Who decides that the towels are next to the bed sheets? Who decides that the t-shirts are next to the jeans? Somebody has had to decide this and design the store, right? And keep those things. Who do you think decides that? Any guesses that who decides that? Who makes that decision that what should a big bazaar store look like? And totally bricks and mortar, nothing online. You walk into a store, you want to buy some, buy some linens, you want to buy some towels, you want to buy whatever else, buy some cups and plates. That decision used to be totally dependent on the store manager, the person who heads that store, with inputs from obviously the experts. Today, there's something called association analytics or affinity analysis, which analyzes and tells you that if a person buys article A, they're also likely to buy article B. If they buy a pen, what else are they likely to buy? That probability is given to you. That people who buy bread, there were 90% chance of also buying butter. There were 80% chance of also buying jam. They have a 20% chance of buying bed sheets. They have a 3% chance of buying, I don't know, something else. This entire thing is given to you, yes, before you take these decisions. So today, what is next to which article or what shows up on your screen when you're buying something on an e-com? So whether it's a bricks and mortar store or whether it's e-commerce store, same thing. It's totally the decision is driven by data. Okay. Um, so let's look at a simple problem, yes? Because the idea is that how do you solve a problem using data? That's our biggest thing, right? That's what we want to get. Yeah. So let's look at something. Let's look at a tangible problem, the kind of problem which is extremely simple, and you can do it in some basic tools like an Excel or something. Yes. The example that we are going to see here is based on Excel. It's based on MS Excel. It's extremely simple. The point about data-driven decision making is that it's not necessary that you need to be an expert in a particular tool. In your first job, is it ideal that you learn SQL and you learn Python? Absolutely. Yes, you better learn those things to get that job. But to take decisions with data, a lot of it, not everything, of course, a lot of it can be just analyzing the data in Excel, visualizing the data using paper charts and pivot tables, analyzing the data and putting together a dashboard in a Tableau or a Microsoft Power BI. If you have Excel, you have Power BI, right? Power BI, the basic edition free to use. You can start tinkering with it yourself. But the idea is that you need to look at a problem and figure out that, okay, how do I use a particular tool to come up with the solution that I need? Like in this case, the question that has been thrown to us is that you need to create a unique ID from the customer database of retail business to analyze the profitable and loyal customers. Okay. So you have a bunch of customers. You wanna build a unique ID for each one of them. Why? Because people might have same names. Everybody calls me Beep. There are probably 100 million Beeps in the state of Punjab itself. Right? You don't even have to go to the rest of the country. I'm not from there, but it's a common enough name everywhere. Now, how does one know, right, that this Beep is separate from some other Beep? So you want to create unique identifications from a database. Right? So now, how are we going to create that unique ID? People having the same name is fairly common, right? But people having the same name and the same address is going to be extremely rare, right? That some here you have a list, right? Florence Rasmussen of 8186 Spring Avenue, Decatur, Georgia 30030, right? Now, it's very, very unlikely that if Florence Rasmussen ever sells the house and goes away or stops renting and goes away, another person who comes into that same address has the same name, Florence Rasmussen. Right? In that case, it's questionable. Okay, it's problematic, but it's very, very rare. Right? So you have the full name and the address, and the task that you have to do is take the first initial from the first name, first initial from the last name, the zip code where they live, which is the PIN code effectively, right? That's 30030. And then once you have that created, you create a 4-digit random ID. Right? So in column A, you have the name, in column B, you have the address, and in column C, you have the desired output. Okay, you just create a random ID. Right? Now, the first thing to do is you've got to break down this problem. Again, we're looking at a very, very simple problem which you can solve on your own using Excel or something, any spreadsheet. Google Sheets would do it, and Excel would do it, and Open Office would do it, anything like that. Yeah, you have these details. Now you want to break this problem down into the smallest possible steps. What are the things that you need? First, you need initial of the first name. Okay, so you're breaking it down into the constituent steps. Second, you need the initials of the second name or the last name. Third, you need to select the zip code, right? Or which is just like the PIN code that we have. Fourth step, you wanna combine 1, 2, and 3 together. So you picked up F, you picked up R, you picked up 30030, and then fourth step is that you want to get them all together. Fifth step is you put a dash in there, and the last step is you generate and connect the random number. All right. So the problem statement that we had, which is a 4-step problem statement, has now been broken down into a 6-step problem statement because that's the smallest level It can be broken down. Right? Now, what are we going to do? We're going to use simple Excel. Right? Because first, we want to identify what are the easily resolvable parts of the problem. Okay? How can you get to the desired output? So you want to shore up the elements of the problem you can solve, create the helper columns that allow you to hold parts of the solution. Right? Now, the easiest thing to do in something like this, right, is to get the first initial. Because if you think of Rasmussen, the second name or the last name, collecting the initial from there is a little bit more difficult. Right? How do you know where the first name ends and this last name begins? By looking at the space between the first and the second. So that's more complicated. What are the easiest things we can do? We know that in the first letter of column A is the first initial of the person. So we create a column D which is left A2, comma 1, right? And then if you drag it down in Excel, you'll see A3, 1, A4, 1, etc., etc. Right? So F, R, F, those get picked up. Another easy one, right? Which is, you know, that in column B, the rightmost 5 characters, right? That's the zip code. Again, very easy to do. So what do? We create a column E, write B25, right? B2, B3, B4, effectively the entire column B, and the last 5 digits of that. Okay, like last 5 characters of that, and we take that together. So write B25, B35, B45, etc. And the zip code gets picked up. All right, and then I can concatenate them using the concat term and get them all together. So we have F300030. Right? Desired output is different. These are just being used as helper columns because we have broken this down. Now, what's the next step? You have to formulate effective searches. How am I going to search for a particular character from a particular string? So in this case, how to select the first character from a string in Google Sheets. Yes. So how can we do that? We can explore the relevant documentation first and see that, okay, what do we have to break down this search? All right. You want to use a toy example and figure out that, okay, we are using VLOOKUPs for student IDs and grades. Look at some simple data, figure out a toy problem, and get to the solution. So anytime we have a problem that can be broken down into little pieces, first step is break it down. The second piece is that take, what I like to do whenever I'm dealing with a data driven problem. Let's say I have thousands and thousands of lines of data. Every time I want to run an algorithm or run Excel, Excel takes its own sweet time. I do it in Python, it's going to take like, whatever number of minutes. I would take a very small part of that data. And the first thing that I would do is get my answers right. Yes? I want to check whether my code works or not, whether my Excel works or not, to collect the data that I'm looking for, to do the basic analysis on that data, to draw a chart from that data. Right? So I like to work with small toy problems. Once I have that sorted, right, I have a data set which has 20 columns and 100,000 rows. I'll probably take 20 columns and 500 rows, right? So which is a very small data set. I'm going to use Excel to figure out what's in that data. And then I'm going to bring in the rest of the data after, because it becomes easier. It helps me to break down the process into little bits and pieces. And then it allows me to solve for those little pieces one by one. Instead of thinking that, oh, I have 100,000 data points and it's going to crash my system and so on. So what should we be able to do after this? You should now be able to identify data sources and types requisite for the analytics problem, recognize the level and decipher the business problem and resolve it using data by bringing in very, very basic steps within data analysis that you want to do. You do not want to start off trying to solve a big problem. You want to start off by trying to solve a very simple problem. All right. So that's what I wanted to talk about today in terms of how to approach data science problems and take decisions based on that. I am very happy to answer any questions that you have in the arena. Again, it doesn't have to be on data science or data-driven decision making. I want to talk about pretty much anything from this industry. I've probably done something or the other, and I've also been teaching this in this world for a decade. So in questions that you might have, I'm happy to answer. Okay, the questions started coming in. Let's see in the Q&A section. We have a question from Divya which says, how can I transition from finance domain to data domain and how is it going to look like? Divya, I'm going to quickly ask you, um, which part of the finance domain are you in? Or the question who you're asking it for? Any specific domain within finance? I mean, I can give you a broad answer for this, and if you have a specific domain that you are in, you can put it in the Q&A or the chat box. I used to work in finance, in financial markets, and then moved, or I used to do more quantitative work in the financial markets. It was quite easy to move into data science. But any domain that you're in, right, whether it's in finance or marketing or whatever, the idea that I like to push for is play to your strengths. There are more jobs, so there are tons and tons of jobs in banking, financial services, and insurance. The BFSI sector is one of the largest for data science, right? For hiring people in data science, and if you already have a knowledge of the basics of finance, right? All you need to do then is to pick up the data science part, add these two, and when you go for interviews, say, you know what, I already know the basics of accounting. I already understand corporate finance. I already understand a lot of the terminology that is used in banks. I know what a journal and a ledger is. That gives you an edge over others who come from a non-finance background for financial analytics roles. So there are business analyst roles in banks, there are financial analytics roles, there are risk analytics roles. The insurance companies are always looking for folks in analysis and data science and so on, right? So there are tons of openings. Yes. Vams, here's a question. I want to venture into finance. What are the skills required and technologies leveraged to apply AI ML in this sector? So since these two questions are connected, I'm going to answer this first, and I'm going to go back to the other questions. Yes. So, what are the skills required? First thing is the basic core skills that are needed to work in analytics. It doesn't matter which domain. One of them is just plain and simple business understanding, right? And problem solving. That how can I look at industry problem, whichever industry it is, and translate it into a data problem? This translation, or how can I look at some data solutions, right, and translate them into business solutions? This translation piece, or the problem solving with data piece, what we were talking about today, right? That is one of the most essential things, step one. Right? What else do we need? The basics of probability and statistics are necessary for anything that you do in the analytics domain, right? Now, certain types of analytics are used in banking a lot more, like linear regression, logistic regression, some basic ML models like decision trees, right, or random forest. A lot of ML models in banking are not used or cannot be used, especially in the regulatory aspects of banking analytics, um, because the outcome from these analyses are often not super stable over time. Okay, with a little additional data, the predictions change very fast in certain machine learning algorithms because those algorithms are trial and error algorithms, like all machine learning algorithms. Yes. So while you will need to understand some level of machine learning, uh, like the ensemble modeling and so on and so forth, uh, learning basic core statistics, right, can actually go a long way in the regulatory aspects. Uh, there is a whole bunch of regulations like PDs, LGDs, EADs, how do we calculate them using Basel II, Basel III, etc., etc. Um, most of them, right? Most of them utilize the exact kind of analysis that I'm talking about. Yes. So the skills and technologies, most of the work that's done in the finance domain, anything that's cutting edge, fintech, finance, P2P, even within banks, right? I'm teaching a bank right now, a public sector bank actually. Um, they are using Python. Anything where you work with US banks who have regulatory requirements, right, under Basel II, Basel III, there you might need to even learn SAS because SAS is still the most accepted in that world, whereas everybody has moved out of SAS, right? US banking and US pharma are still clinging on to it. Very difficult to remove the legacy. Everybody else is moved to SQL again is a common skill. It doesn't matter whether it's finance or any other domain. It's something that will be essential to you. Yeah. So Vamsi, I hope that answers your question. I have another question. I'm fresher in data science. All right, you're welcome. I'm fresher in data science. How can I start my career in data science? Well, the first job is always the most difficult one, no doubt. Um, um, the if you do not come from a technology background, right? And like I did not, I come from a background which is extremely mathematically heavy, right? So that was helpful. But over the past decade, I have students who come from BA backgrounds, econ backgrounds. I have students who are medical doctors, right? They're like MBBS doctors. I've had 4 or 5 doctors who are doing fantastically well, by the way, in the public health domain using analytics in public health. I've had students from MassCom, right? Um, who are working on data visualization and doing quite well for themselves as well. Uh, so the easiest way to break in is to do a program. Let me be honest. And again, I'm not selling you a program because my life or job or finances don't depend on selling programs. Uh, I teach, and that's what I do, and I consult. The easiest way to break in is to do a program where you can learn things in a structured manner. When I broke into the business, as I said, 19 years back, there were no data science programs. The term data science was not used back in 2003. Um, Today it's everywhere. So when I moved into the quantitative finance role, I had done economics and a lot of econometrics, right, which is fairly advanced level statistics. So that really helped me. But when I wanted to signal to the broader world that, hey, I know a lot of finance, okay, because I was working in quantitative finance, I went and got a CFA charter because it's a signal. Once you do a course or get a charter or get a certification, it's a signal saying that, hey, you know what? I got certified, I know this stuff well. That's probably the easiest way to start. There are other ways to start as well, right? And even when you do a program or a course, whether it's with Wired or with anybody else, it's not enough to do that course. You have to learn, you have to push yourself. I tell all my students to go open Kaggle accounts, right? And showcase to the world what they can do. To open accounts on Tableau Public, where they can put up their visualizations. Make sure they have GitHub accounts. Make sure they have accounts on HackerRank and HackerOut, right? These are all ways for signaling to the broader world that hey, I can do this stuff. All right. Okay, I hope that answers your question. We have one more question. I know we're a little over time, but I'm going to take that. How can wired programs help you? Well, again, it what it does. The first thing that it does, right, is that it gives the market a signal saying that you're serious about it. The second is the learning aspect because all the faculty members at Wired, like myself and everybody else, you have folks like Gaurav Singh, who has got 15 years of experience in the field. Vishal Nyungi, who's also got 15 years. They work with companies like Genpact and Symphony and Lowe's and IBM and Axtria, really big names, right? They're people who have actually managed multi-million dollar analytics projects. So, and now they're full-time
teachers, they're full-time faculty members at Wire. Yeah, that I think is the biggest power of the Wired programs. The syllabus, of course, is great. I was deeply involved in the design, and I got infected by many of my friends in the industry. So of course, I like the syllabus. Um, but it's the faculty. They are not people who have done a PhD in the subject. They are people who have actually implemented large-scale analytics projects across different domains. Vishal used to work at AbbInBev, which is the largest liquor company in the world, or the second largest, I think. The Pernod Ricard's guys are the first, AbbInBev is the second, or the other way around. I think AbbInBev might be the first, right? It's Anheuser-Busch and InBev, they merged a few years back. And they do a ton of very, very high level analytics for customer management and everything, right? Marketing, they spend millions of dollars in marketing across the world. So Vishal used to work there that was, I think, his last role. Yeah. Gaurav worked in Axtra where he consulted with, Fortune 500 companies, right? So even the younger people, right? We also have Nina, who's doing her PhD. She's been around for a long time. She's been teaching analytics and data science. Gunwant used to do consulting before. Um, I think the big USP of Wired is that not only is the syllabus, the material, the in-person teaching, the content, everything is designed by people who do this for a living, right? Like myself, I mean, that's what I do for a living. I run a consulting firm where I work on data science and ML AI projects with clients across 4 different continents. Right? Um, that's my bread and butter, and I also teach at Wired, right? So I think that's the big upside, and also the career transition team. We have the careers team, which is doing some fantastic work with our students. I think a lot of the programs have been now made guaranteed placements. Right? I don't know which of them, but there are quite a few of them which are short placement programs. So what the careers team would do is they would do like these mock interviews and everything that I was talking about, like opening a GitHub account, a Tableau account, etc., etc., to signal to the world that you're serious about this. They'll make you do that. They have one-on-one career coaching and things like that, right? So they put in a lot of effort because they're responsible for you. They're liable to get you a job. So they put a lot of effort to transition folks from different career paths or from fresher, being a fresher to actually being job ready by the end of the program. Yeah, I hope that answers your question. All right. Any other questions? I'm happy to take them. We are a little over time. I know we're a little over, about 5 minutes over time, but is there any other questions? Ah, Ramsey says, how to showcase your expertise to companies based on skill sets and good knowledge in AI and HRs are gauging me on years of experience, projects on Git and digital portfolio with double certification. The priority is given only to years of experience. Yes, I know, and that's a big challenge, right? And which is what when we're talking about the courses, that's the big upside that you have a support team, right? Which will get you to those interviews, right? But it's a serious challenge of for folks who are doing it on their own, right? That when they do apply, right? I would say target smaller organizations, target startups, target young consulting firms, new companies which are more flexible. Your larger companies, they are just extremely inflexible because nobody wants to take the risk. Right? So if you think about the Wired placements, a lot of our experienced students, right, who come with 5-10 years of experience and are transitioning into careers in data science. A lot of them are moving into small to mid-sized organizations because, like, I run a small company. I am happy to take a risk on someone who comes from some absolutely random background, but who's kind of really serious about the kind of work that they do. they do and can showcase that. Yeah. If you think of a company which has 20,000, 30,000 people, the HR will never take that risk because if it backfires on them, right? The only reason why they'll take a risk is because if someone like my colleague Ankur or somebody actually talks to them and says, hey, you know what, this kid is good, give him or her an interview because there's a personal relationship there. Ankur heads career services at Wired. And he knows, like, it's unbelievable the amount of people he knows. He knows everybody. I keep talking to him and I keep asking him that, how big is his like phone book? Yeah. Um, but other than that, if I tried to, walk in to a role like this in a large organization when I was, let's say, with, if I had your background with your age, uh, yes, it wouldn't be easy. Yeah. Signaling, of course, helps, but if you have that connect uh, through which somebody's willing to take that chance, right? And which is, as I said, this is what I see a lot in the career transition stories in Wired. That a lot of them probably get certain interviews or get that first transition because they had a support team. And then once you take flight in this discipline, then you're set. Then it's all about quality. Right? It's that first transition which is absolutely, which is the major pain point, which is why a lot of our students, when they come in with experience, they talk about that how do I do my first transition? What's the structured learning path that I should use? How should I prep for certain kinds of interviews and things like that? I mean, and that's where the coaching, the counseling, the industry expertise helps. But I'm totally with you. Just the signaling is helpful, but without that support, it's not super simple to break it. The only way is to try for smaller companies, but there the number of people they're hiring is going to be quite small, right? I mean, a Genpact probably hires 20,000 people in analytics every year, whereas a startup might hire two every year. So you have to go to 1,000 startups to find as many job openings, which is painful. No, that is not an easy thing to solve on your own. It's not simple. It's not simple. It can be done. I know people who have done that. It can be done. Do not get disheartened, but it's easier with the support team, kind of getting that uh, foot in the door, if you will. Yeah. All right. Any other questions from anyone?
I don't think so. We have any more questions now. So we can just quickly wrap up this session. Thank you, Deep, for a wonderful session. That was a very informative session. Thank you, everyone, for being a lovely audience. In case you have any doubts and any queries regarding the program or the webinar, you can write us at hello@herowire.com. I'm also putting it down into the chat box so that you can look there. Thank you so much, everyone, for joining. We will be connecting with you soon with an informative webinar. Thank you so much for joining. Thank you, Deep.
All right. Thanks, everyone. Thank you so much for your time. And Vamsi, you might have, it seems like your sessions are always very educational. You might have seen more of my sessions than I would imagine. But great. Thanks a lot for saying that. Really appreciate it. All right. Thank you, everyone.